Introduction at the beginning, we may as well just get going so that we have enough time to do everything. All right, so there will be a couple of these questions on the test, folks. Solve these algebra problems where it will be just straight algebra, okay? And the numbers will not be really, really painful. Not, the worst thing I would throw at you is a 2-digit number, okay? That's it. So this will actually show up on the non-calculator portion of the test because you guys can add and subtract 4 and 5 and 6 and what. Okay. So, what would I do first in the top problem? Distribute, right? Just make sure that you distribute the 4 to everything. I've seen a couple of times where people have just said this is 4x minus 2, and that's just you going too fast. Please don't do that. Okay? Now, what do I do next? Add the 8 to both sides. 4x equals 28, and then what do you do last? Divide by the 4, and that'll give you x is equal to 7. Give me some room. All right. And again, my advice, once you get the solution, make a quick glance and make sure it makes sense, right? What's 7 minus 2? 5. What's 4 times 5? 20. Okay? Looks good. We feel like that's the right answer. Just check. Because you might make one of those accidental mistakes where you divide 28 by 4, and for whatever reason it turns into 24. Because what did you do instead of divide? You subtracted. It happens, folks, right? So, check. All right? How about the next one?
Distribute again.
Distribute again, right? 8x minus 40. Please be careful distributing the minus 3, folks. Right? This becomes minus 3x minus 12. Again, that's the one thing that sometimes happens to students is that minus sign all of a sudden stops getting distributed along on the trip. Please don't let that happen. 8x minus 3x. 5x's. Be careful with the numbers. They're both negative, right? A negative 40 and a negative 12. When you add those, negative 52. Please be careful with that. And then last, not quite last but not least, now you've got it simplified into a straight problem that we've worked a few times. Add 52. 5x is 75. And last but not least, to divide by the 5. X is 15. Okay? So again, this is as scary as the algebra gets, folks. This is it, okay? But you gotta be able to do it.
For the first problem, is it okay just to divide by 4 right off the bat?
If you want, yeah. Since this multiplication is outside parentheses, you could divide by 4 first.
Okay.
And the cool thing about it is that when you divide by 4 first, where do you still wind up?
Yeah,
It won't matter either way. Just realize that if you have 4 times the quantity x plus 2 and then plus a number off to the side, then kill it. Alright? Alright, so how about that first word problem? Jim has 4 more dollars than Manuel. If they have a total of $142.50, then how much do each of them have? So, when you are doing word problems, folks, take them one sentence at a time. So I know it's really hard not to say, well, I know how to get the answer right now and start doing it. Stop yourself. Think a little bit, okay? First off, I'm trying to find 2 people. Jim and Manuel. Which of those 2 is going to be X?
Daniel.
Why?
He's last.
Because he's last, right? Whoever is last when you compare two unknown variables, that's who you make X. So if Manuel is x, what is Jim going to be?
4 plus x.
4 plus x. Note, folks, be careful with that one, right? More is a plus. And again, this is where students sometimes make a mistake because that turns into 4x instead of 4 plus x. So just be a little cautious. That's the first sentence, setting it up. What's the second sentence give us? Total. What do you do when you total things? They equal, but what does totaling require? Adding, right? We need to add Jim and Manuel. So again, think of 4 plus x as Jim and x by itself as Manuel. When you total them, when you add them all up, that's what's going to get you what you're looking for. Once you get the equation, then it's algebra, right? And it's not overly complicated algebra. It's the type of algebra that we should be relatively comfortable doing at this stage, right? So subtract 4. 2x equals 138.50. That's a 5, that's square. And then last but not least, cut that in half. Just barely have enough room here. X equals 69.25. Now, if you stopped right there and just told me that x is 69.25, what would I do to your paper?
Put a big x.
Yeah, I would probably put a little bit of an X on that one. Because what did the question ask? How much did each of them have? You only gave me one number, 69.25, and there's no label on it. I'm going to be pissy about that kind of stuff. Okay? I was not pissy about labels on the homework. On the tests, I will be. If you don't write $2 signs, it's going to cost you at least a point. All right? And if I'm feeling a little bit peckish, it'll cost you 2.
So grade my paper first.
Usually it has to do with, how much consumption happens before the test or during the grading of the test or whatever. And we'll leave it at that. Anyways, please indicate in some way how much each of them have. Note that you set yourself up a little setting that says, here's Jim and here's Manuel. Just write them down right there. That's perfectly good. I'll be happy with that, right? So tell me that Jim, or that Manuel, who is X, has $69.25. And so, since Jim is 4 more than that, how much does he have? $73.25. That would get you the full points, okay? And even if you wrote it as sloppy as that, I would see it and say, oh, good, no problem, okay? And the cool part about this, folks, is that you can actually make a quick check and see if your numbers make sense, right? If you add 73.25 and 69.25, what do you get? 142.50. That's the number that you were looking for. Okay? So, this is a very good approach to tackling word problems. One sentence at a time. All right? So how about the next one? Variation on the theme. All right. So this time Manuel has 4 times as many dollars as Jim. They still have $142.50 though. How much do each of them have? Now that you guys have done one of these, now you sort of have the feel, right? What do I do first? Who's X? Jim or Manuel? Who is X this time?
Jim.
Jim, right? Because Manuel is 4 times as much as Jim. Jim is X. Manuel. There's the 4x, right? Because now it has the word times as opposed to the word more. Okay? Just, again, be a little cautious. And then again, it says the total is 142.50. Now you see, take the 2 of them. I'm getting the answer before I write it down. X plus 4x has to be your 142.50. A little bit easier because there's no numbers floating around. X plus 4x is just 5x. Divide both sides by 5. What is that, 20 something?
28.5.
2850. And again, answer the question. Take that 2850, which is X, and bring it over to your table and say, oh, that's Jim. Jim has $28.50. How much does Manuel have then? What was that?
I got 114.
114. How'd you get 114?
Because 2850 times 4.
Yeah, 2850 times 4. That's what 4 times as much means. So multiply by 4, you get 114. And what are you going to do with those two numbers to do your quick check? Add them. Make sure they add up to 142.50. Okay? Not too bad? Alright, there were definitely variations of the theme on this in the homework, so. Oh, I like this next one. 1, because it's true. And 2, because it's got a fraction 2/7 in it. Anytime you have a problem with the fraction 2/7 in it, it's just a good problem, period.
Because it's a 7.
Because it's a 7, exactly. Because that's how many slices you cut your pizza up into. 7s.
I told my parents that, and they said they were weird.
What the dog?
I'm not going to disagree.
My wife just laughs at me at this stage. She's just like, I'm like, what?
They were really confused, and I was like, he cuts his pizza into 7s.
All right, so how are we going to deal with this one, folks? My shoes cost 2/7 of the cost of my wife's shoes. Whoa. Fraction followed by the word of, folks. Multiply. I mean, there's sort of implied division with fractions in it, but you are going to multiply. All right. So, first off, folks, where's the verb in that sentence?
I thought this was math class.
No. Math class is at least 25% English,
I
folks.
don't know about that.
Yeah, it is, because 25% of my, well, folks, 100% of my questions will be word problems.
Cost the word.
Yes, cost. Exactly. Here, technically, folks, is the verb. Remember that that's the equal sign. Always. Okay? So everything that's before it is to the left of the equals. Everything that's after it is to the right of the equals, right? And so note how I'm going to write this math. I'm not going to use x's and y's. I'm going to actually use words in the problem, right? My shoes equal 2/7 of 2/7 times the cost of my wife's shoes. Wife's shoes. So instead of saying that my shoes are X and that my wife's shoes are Y, no. Just write the words out there. It's okay, right? There's nothing wrong with it. It's one of those things we get a little bit carried away with. Well, we always have to use X and Y because it's algebra. And I'm like, use stuff that makes sense, right? Because what does the second sentence tell us? Her shoes are 110. What am I going to do with that 110?
Replace it with a
Yeah, put it in where you wrote my wife's shoes. Perfect. So my shoes equal 2/7 times $110. How are you going to figure out what my shoes cost? Exactly, right? Make 110 over 1.
Do you just change it to a decimal?
Well, this is money, so you better. Right? This is a word problem with money. You know where to round these things. Don't give it to me as a fraction this time. It's money. Give it to me in dollars and cents, right? So when you get 220 over 7, it is in dollars, but you should know where to round it. So take 220 divided by 7 and tell me how much I pay for my shoes. 43. Round correctly, please. And label correctly. So my wife's going to pay $110 for her shoes. When I'm lucky, I find my pair of shoes for $31.43. And again, this is one of those where your gut instinct may have been, well, just take 2 sevenths and multiply by 110, and you would have wound up being correct. But this way, by writing out all of the algebra, you're like, oh, yeah, it follows. Okay? We'll do another variation on that theme like that in a little bit. All right. Everybody good with that one? Okay. I like that one. That one often shows up on the test, just so you know. All right, so how is this problem a little bit different with Jorge and Mary?
I'm going to turn it into this mixed number to be able to multiply it correctly.
True, but what else was there? I heard it from somebody. More. There's another word in there, right? When we were working with me and my wife's shoes, it was 2 sevenths of, we just multiplied. Here, we're going to multiply, but there's also that word more after it.
Then you're going to add them.
Yeah, you have to add them together, right? Jorge paid 1 1/3 times more for his car than Mary did. So, yes, you're going to have to multiply 1 1/3 times something, but that's the more amount. So if you actually want to know what Jorge paid, you're going to have to take his more amount plus Mary to get you to how much he paid. Okay? That's the difference between saying he paid 1 1/3 times as much and 1 1/3 times more. And again, it's a very subtle difference. This is why this is more of an English question than it is a math question, right? The math is not overly complicated, but it's the English that says, well, should I add or should I not add at the end? And that's where you look for the math words to tell you which one to do, right? So, here, Jorge equals 1 1/3 times Mary plus Mary, because it's 1 1/3 times more. All right?
You do that on your head.
Yeah, I mean, you should be able to do it a little bit in your head, but it's just one of those where if you note on the test, it's going to be 3 4/7, and the numbers could be. Yeah. So yeah, this one you probably could do in your head, right? 1 1/3 times 15,000 plus the 15,000. What is 1 1/3 times 15,000? 20,000 plus the 15,000. Again, that's how much more he paid. And so you need to add it on top of Mary to figure out that Jorge spent 35 grand on his car. Okay? Again, it's one of those. It sounds like it's nitpicky, but it's not. It's very important as to whether or not you add or not. And on the homeworks I saw them too often. People were like, well, I always add because that's what I've always done all the time. And I'm like, no, read. Sometimes you do, sometimes you don't. All right? All right. Here we go. Now into the fun ones, right? Did I give myself enough room on all these? Yeah, I maybe did. All right, so how about the books and trophies one? Bought 5 more books and trophies. Books cost 12, trophies cost 13. Spent $42.60. What am I going to do? Good idea. Make a table thing. Now, what do we put in the table thing, folks? Books and trophies. Quantity and price. Because remember, the idea here is that price and quantity give you the total amount of money that you have to spend, or the total amount of money that you actually spend, right? Price of a book, $12. Price of a trophy, $13. And note, folks, this table at this stage gets you 3 out of 10 points. You haven't given me an answer. You haven't done anything other than to create a little table with the most basic, obvious information in it. All right? But that's still 30% of the way. All right? Now, the quantity. one of the two things needs to be X. Which one is it going to be? Why? Because I bought 5 more books than trophies. Awesome. Trophies are X. What are books? Five X or X plus 5? Why X plus 5 and not 5X? Because it's more, not times, right? Remember the difference. And again, remember, we tend not to write it, but I honestly wish you guys would all the time. Put it in parentheses, okay? Because what do you do to get money when you have the price and the quantity? Yeah, multiply, right? If you bought 8 items at $2 each, you would tell me, well, you spent $16 because that's what 2 times 8 is. So that's all you're doing here, right? When you're filling out this table, you're just figuring out the price and the quantity and then saying, well, I know what the money is because it's times the two of them, right? So when you multiply the top row, 12 times the X plus 5, distribute. Right? And then when you multiply the bottom row, just let it multiply, right? Now you've got at least 5 points, folks. Again, you have yet to do any math. You did a little bit because you did distributive property, but you're halfway to the problem, but you have done essentially 0 math at this stage. All you've done is then translate the English. What is the math, folks? Yep, add the money up. The money for books and trophies has to add up to the money that I told you. 12x plus 60 plus 13x has to be 4260. Okay? Math is always show me the money. Combine your x's. $25x plus 60 equals 4260. And then do your regular solving the algebra, right? This is the part that you guys are good at, I hope. Subtract 60 from both sides. 25x is 4200. And then last but not least, divide by the 25. And what did x work out for this? 168, that sounds about right. And again, please don't stop there. That's worth about 7 or 8 points out of 10. Because technically, all you've done is said what x is. I don't give a crap about x. What I care about is how many books did I buy? Because that's the question I asked. X is trophies, X plus 5 is books, so 168 plus the 5, 173 trophies, books. And you're more than welcome to share me additional information, like there were 168 trophies, that's perfectly fine. But just make sure that in your answer, you at least answer the question I asked, okay? And note that I can ask other things too. I can ask about the money you spent on books or the money you spent on trophies. And just remember that that table will give you any of those pieces of information that you need. All right? Good? Okay, I can guarantee you there will be one like this on the test. Okay? I mean, change it from books and trophies to, you know, apples and bananas or whatever, and you'll probably have it. All right. Now, how about the next one? Salt and pepper again, because we're in Wisconsin. We don't have any other spices here than salt and pepper.
Looking under salt and pepper.
Well, if you put anything in if you put any other spice into food in Wisconsin, then you have to call it spicy, right? Right?
No, I don't know where you're getting that from.
At least that's The sad thing is my wife grew up in Iowa, and so her family is that way. I mean, if there's anything in there other than salt and pepper, they're like, oh, this is some kick to it. And I'm like, what, because I put some ginger in there? I mean, come on.
Maybe
Anyways.
there are spices that aren't spicy.
True, but the problem with it is that for them, if it's not salt and pepper, it's spicy because it's flavorful.
I think we're
Okay,
doing
let's
You
see
just
what
don't
else.
understand.
Okay, so $5 for pepper, $2 for salt. Container's worth 119. All right, so what am I going to do to start? Salt and pepper. Price, quantity, dollars. How much were each of these? Salt was 2, pepper was 5. Okay. Now, here's the fun part. Which one's X? Pepper. Why pepper? This was last. Okay, cool. If pepper is X, what's salt, folks? 35 minus X. Why is it 35 minus X? Because the total has to be 35, right? If I told you that we had 5 pounds of pepper, you would tell me that there's 30 pounds of salt. Because you take 35 and subtract the 5. If there were 10 pounds of pepper, you'd tell me that there were 25 pounds of salt because you'd say, what's 35 minus 10? Gets you back to 25. You're always going to subtract it from 35. So the key is, if the pepper is X, you still do the same thing, just use X. Okay? That is the classic trick when you are given the total amount instead of a relationship. All right? Figuring out the money? Same as before, right? Multiply. Again, remember, there's parentheses. 3 times 35 is 70. Don't forget to distribute the 2 to the X. Pepper, 5 times X. What's our algebra? $70 minus 2x plus 5x. The money has to add up to the money, $119. Now, you now have the algebra, right? Now it's just a matter of solving. Again, please be careful, folks. This is a minus 2x. A minus 2x plus a 5x. What do I do next? Subtract 70 from both sides. 3x equals 49. Last but not least, divide by 3. This is an annoying problem. Welcome to me. What are you going to do with that 16.33333333333333333? What did the problem tell you to do? Round to the nearest hundredth of a pound. So what am I going to do with the 3's repeating forever and ever? I don't have to worry about all the repeating. I can round to the nearest hundredth at 3, 3. Okay? So am I done? Is that my answer? 6.33 pounds? Why are you shaking your heads? Because that's pepper. This is why you have to be careful going back to the table. My question said how much salt is in the container. Salt is 35 minus X. Pepper is X by itself. So 35 minus 16.33. What did you guys get?
18.67.
18.67 pounds of salt. All right? And again, the reason why I have problems like this is because there's no way to hunt and guess that answer in any way, shape, or form. If you're the hunt and guesser type, this is going to take you forever to find. Okay? I have a lot of people who know that you can find these answers by just guessing numbers, right? Because you know they have to add up to 35. Start guessing numbers that are that add up then, right? Try 10 and 25. Try 15 and 20, and you can keep getting closer and closer and closer, but it's a real pain in the butt to get to the hundreds. Okay? I mean, you can do it, but it'd take a while. If you just learn the algebra, it'll come a lot faster. Okay? All right. So one more, just to be safe. Buying shirts and socks. Again, it's got prices in it, so, and total dollar amounts, you're going to need the table.
I feel like buy some if they don't last long.
Isn't that, a pair of socks for $5 is expensive, isn't it?
That's cheap.
Well, I mean, yeah, that's on the cheap
Well,
end.
yeah. I mean,
Well, I must buy cheap socks then. I'd buy a pack of 10 pairs for like $12, right? I mean, isn't that how you guys
No.
do it?
no.
No? Oh, okay. I thought I was being really... Alright, so shirts, $25. Socks, $5. Which one's X?
I think shirts can't sometimes because you have to use 7 times as many socks anyway.
I bought 7 times as many socks as I did shirts. Which one's last?
Shirts.
Shirts. So yes, shirts are X. And so what are socks? 7x, right? And this is the 7x because it's 7 times as many. How do you get the money?
Can you give us more space next time?
Yeah, we got no space.
Oh yeah, sorry, that one was... Before those were all on one page and the font was really, 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 really small. So I expanded it to 2 pages, but then killed the margins. Sorry about that.
Okay. I'll forgive you this time.
That's nice of you, thank you.
You can just give us an extra point or 2 on the test.
25x for the shirts. Socks, what are they going to be? 35x, right? Because you're just taking 5 times 7x, that's 35 x's. And at least when you do times, the problem is usually a little bit easier because there's no numbers floating around, right? It's just 25x plus 35x is 900. $25x's and 35x's. 60x's are 900. Divide by your 60. X is 15. And then again, don't forget to answer the questions that I asked. What did I ask?
How many of each?
And how many of each did I buy? So what does X represent?
Shirts.
Shirts. 15 shirts. How many socks? 105. Apparently I have a sock fetish.
Now, did you buy 105 individual socks or 105 pairs of socks?
Good question. Potentially these are actually individual socks, and so $5 for a
You
sock.
just have a floating sock around?
Boy, I always have a spare floating around anyways, right? So this way then when I lose one, now I'm actually back to even.
Is those trendy things match socks?
That's right, nothing ever matches anymore. So that I can truly have a different pair of socks every day of the year.
No, your socks have to match.
Yeah, I know.
No, I don't, ever.
Mine have to match.
Mine have to match.
No, I can't even find the other sock.
When my socks don't match, I walk around and show people all the time. So, because I'm weird. Whatever.
We know.
All right, so any questions on the Chapter 5 review? How about questions on the chapter 5 homework?
Nope, she's got one. Number 28.
Number 28.
You're crying, but okay.
Alright, so read number 28 to me then.
Staple 4 boxes of pens, $10, and rubber
Oh. Pens, $10. Okay.
and rubber bands, $4.
Rubber bands, $4. Okay.
Fiona ordered a total of 24 cartons for $210.
24 cartons?
Yes.
Total of 24 cartons at 210?
Yeah.
Okay.
How many boxes of each did Fiona order?
Okay. So, you've got prices, and they told you a total dollar amount. What do we need to build? A table. Wise maneuver. Pens, rubber bands.
Instead of 1 and 10,
What was that?
Pens and pens.
Oh, it actually gave you a hint in theory. Pens are $10. Rubber bands are $4. Which one does it say to be X? Said make pens X. Okay, that's right. So if pens are X, what is rubber bands? Bingo. 24 minus X, right? Because they gave you the total number of cartons, not a relationship between the two.
Why would it be minus?
Well, if there were 10 cartons of pens, how many?
Okay.
Yeah. Immediately, as soon as you figure it out, you'd be like, oh yeah, oh yes.
That's right.
So what are my dollars? 10x and 96 minus 4x. Again, remember that you distribute through that 24 minus x. Again, that's the one thing that I want to make sure you guys get when you do this on the homeworks and tests, because you will have one like this on the test. Maybe.
I'm sure of it.
What's the equation then? 10x plus 96 minus 4x equals the 210 that they say we spent. Turn the crank, solve the problem. Again, 10x's minus 4x's. Subtract the 96. X equals, what is that? 114. Okay, I'll buy it. And then last but not least, divide by 6. How many x's do we have in theory? 19. And again, go back to your table. Where did you put x?
Pens.
Pens. Therefore, how many cartons of pens? 19. How many cartons of rubber bands? 5, because that rounds out to 24. 5 cartons of rubber bands. The book problems, normally when you get one of these, you can just sort of go through the possible carton combinations and get it, right? So try 10 and 14, see that it doesn't quite work. Go up to 12 and 17, see that it doesn't work, go the other way, etc. I mean, that's not a wrong way of doing it. Book problems are almost always whole numbers. I will warn you that my test is rarely whole numbers.
You can do them all in the book problems besides scoring. It's the only one you can
Yeah. Yeah, number 40 is fun too. Not bad though? You guys will be able to do one of those on the test. Huh?
I'm gonna try.
Okay, good. That's the right spirit. All right, another one?
16.
16? All right, which one? What does number 16 say? T-shirts for $2.
And shorts for $4.
Shorts for $4.
In April, total sales were $600.
$600.
People bought 4 times as many T-shirts as shorts.
4 times as many T-shirts as shorts.
In the beginning it says that sells a total of 250 T-shirts, $2, and shorts $4.
So wait, which one is this? 4 times as many, or total is 250?
It
Oh,
just-
or whoops, I read the wrong one. I'm so sorry. I read 15 says 6.
This is the total of 250 of them.
yeah,
Total 250 items. Okay.
Awesome. The same question, but weird.
Okay. So this is essentially the same type of question we just did. So which one do you want to make X? Cool thing about it, folks, is it doesn't really matter. No, it doesn't really matter. So this time, let's make the T-shirts X. I know the problem tells you to make shirts X, but let's do it the opposite way, just to show you what it looks like, okay? And so what are my shirts going to be? $250 minus X, right? Because this is another one of those where they gave you the total amount of items they sold, as opposed to telling you 2 more than, or 4 times as many, or whichever one you were doing. So again, getting to the money, 2x, and then again, remember, distribute, because this is in parentheses. And you'll see why in a second why I want to go through this problem like this, just so you can see it. Because what's our algebra, folks? All right, 2x plus 1,000 minus the 4x gives you 600. Why are you freaking out a little bit?
it's going to be a negative
Because we're going to get a -2. It should freak you out a little bit.
2.
But once you stop and think about it, you'll say, oh, that's okay. Because what are we going to do in the very first step? Subtract 1,000. When you subtract 1,000, what's going to happen on the other side? You're going to get another negative. And when you take a negative and divide by a negative, positive. Oh. Since we closed the door, I get to sing. Negative 2x equals negative 400. So now we can divide by the -2 and we'll get a positive number and we feel a little bit safer, right? So now divide by the -2. And what is negative 400 divided by -2? Positive 200. And note, you'll get the same answer either way you put x. If you put x as the T-shirts, it works. If you put x as the shirts, or as the socks, it works. Whichever one is which. All of it works, okay? It's just you're going to find the other side of the coin when you find out what x is. So 200 represents our T-shirts. So how many shorts do we sell? 250 minus that, hence 50 shorts. So yes, be able to deal with that total thing, where you have the total number minus x when you're setting up your table. Alright? And again, like I said, the cool part about it is that technically when you do these problems, it totally doesn't matter which one you call x. It'll work both ways. If you get plus x's or minus x's when you're doing your algebra, it'll still be fine, right? Regardless. One more?
Let's do
40? Alright, which one's number 40?
So a group sells 16 million single-family houses.
16 million family houses? Holy crap.
$60 million.
Oh,
Sorry.
okay, okay.
Single family houses and townhomes. So that's the total.
$16 million. Cool.
A year, with an average selling price of $250,000
For the house?
For single family.
Yeah, for a single family house. Yeah.
Single equals a quarter mil.
Selling 3.5 times more often than townhouses,
Which sell at like
which average selling price at $190,000.
190,000. And sells 3.5 times.
Yeah.
Okay. So, table.
How many each are sold?
Yeah, you're good looking.
Okay. I probably didn't make it big enough because there's all those frickin' zeros. Alright,
Got
so.
zeros. Put them in the letter. You like doing that.
True. I can do the letters if I want. Single family houses and townhouses. Price of a single family house, $250,000. Townhouse, $190,000. Which one was 3.5 times?
The single family house.
Single families are 3.5 times the townhouse. So which one's X? The townhouse. And so the single family house is 3.5 times X. Hmm?
No, just a light bulb.
Nice.
Like,
How am I going to get the dollars? Multiply across. I can do the townhouse one. 190,000 X. What's a quarter mil times 3.5?
875,000.
Unpleasant numbers, but just numbers with a bunch of zeros in it. No biggie, right?
I mean,
It's just ugly. That's the problem, right? And so then your algebra is just make sure the money adds up, right? So 875,000x plus 190,000x has to be that wonderful number, 16 million. It's just, I mean, it's not painful, it's just ugly, right? It's like, zeros, yeah. So 1,065,000x. You got to add it up, right? Is 16 million. What are you going to do to get x by itself? Divide by your 1,065,000, which is something you do every day, right? And so what did you get when you did the division? 15.0247, blah, 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 blah. What did the problem tell you to do? Round to the nearest whole number, right? Because these represent houses, right? You're probably not going to sell 15.02 houses. That would be weird. I'm asking how you sell 200ths of a house.
you sold a fixer-upper.
That
There was only a kitchen sink.
was, yeah, they sold you the garage. That was all you got. All right, so note, what does X represent? Townhouses. So it's 15 townhouses. Now, how many single-family houses did we sell?
Multiplied by 3.5.
Multiply by 3.5. What's 15 times 3.5? What was that? 42? 47.5? 52.5?
Sold that at the house.
What did it tell you to do about the decimals? 53. Just make sure that you follow the directions. I mean, you still have to multiply by the 3.5, but yeah, in theory, you could sell a half a house if you have a
They're
duplex.
called mini houses and they give you freedom.
Yeah. Or if it's a duplex or something like that. But remember, these are called single-family houses, so I don't think you can get away with selling half of a single-family house.
Half a family's house.
Run dog.
So it's just the mom and a kid. Add another kid are gone.
Put the mother-in-law on one half and the rest of you on the other. Would that work?
Put them in the garage.
All right, so those are your Chapter 5 homework problems, folks. If you are happy with your Chapter 5 homework, I would love to have it. You are more than welcome to turn the homework in on test day. That's fine if you want to hold on to it. No problems with me. And then we've got, 10 minutes left? We can go back and do some of the other review questions from Chapter 2 and 3. So what do you guys want to review?
Can you do the third one for chapter 2?
The third one in Chapter 2?
Yeah, for the 3 1/3 pounds of sugar.
3 1/3 pounds of sugar? I like that one.
I think I should part of
All right, so why is this a slightly tricky problem, folks?
Because that's something you use to get sugar.
3/5 of the sugar, right? So how much sugar did you actually use in this problem? You can cheat if you want. But we use 3/5 of the sugar. So what would the of be? Multiply. The word of following a fraction is always multiplication, right? Because the problem is that it didn't tell us we used 3/5 of a pound. It told us we used 3/5 of the sugar. We need to know how many pounds 3/5 is. And in order to do that, you have to do the 3/5 of the sugar, right? How do we multiply fractions, folks? Nicely enough, what's 3/5 times 10/3? 30 over 15. How do we normally write that number? 2. And that gives you the actual number of pounds you use, okay? That's the trick, is reading that carefully. The 3/5 of the sugar takes a multiplication before you can do your subtraction, right? So now, how much is left after you use 2 pounds? 3 1/3 minus 2 is 1 1/3 pounds left.
And you could have done the reciprocal, the complementary fractions.
If you'd just done 3 1/3 times 2/5, you'd have gotten to 1 1/3 in one step. I like this one too. Hint, hint.
What do you do next?
Next one? Ooh, that's a tricky one. I asked this one once on a test, and after the number of people that cried because of it, I will never ask it ever again.
You know, people legitimately cry over this.
Yeah. When I have a test question that makes people cry, I tend to throw it away.
I would hope so.
All right, so you've got 24 2/3 feet of rope. You're cutting into 5/6 of a foot pieces.
That's awful. Would you just divide?
Exactly. That is exactly what you do. If you've got 24 2/3 feet, and you're cutting it up into 5/6, 5/6, 5/6, and hopefully, as you're cutting it up, you see that you're dividing it into equal sizes. Equal sizes means division. That's what it means. Okay? Again, this is another one of those physical interpretations to division that we sometimes miss when we're learning it when we're young, and forever I constantly am like, oh guys, this is what division means. Most people who are like, long time carpenter type people immediately read 24 2/3 feet and start thinking, why didn't you just write it in inches? Yeah, because then you won't have any of the stupid fractions. But I like fractions, so I get to write it as fractions. But yes, the whole idea here, folks, is that you're going to take 24 2/3 and divide it by 5/6. How do we divide fractions again? This will be a non-calculator question.
You've got to be kidding.
Can be.
No.
Yeah, why not? It's not a painful number.
How are we going to check our work?
I need to check your work.
Yeah, we need to check our work. to make
Yeah,
sure.
do some long multiplication and long division. That's the way you check it.
Check it.
You're going to cut pieces that are 5/6 of a foot long and like start adding them together.
That's the questions too.
All right, so yes, folks, the way you're going to do this is do the division, right? How do we divide? First, make this an improper fraction. 74 thirds divided by 5/6. How do we divide fractions?
Invert and multiply.
Yeah. 74 thirds times 6/5. 1, 2, pull a 3 out of those right off the bat. 148/5. That's not too hard to do, right? 29 3/5. So, how many pieces? 29 full pieces.
And then
29 full pieces. And 3/5 of a piece. Note that these are pieces, right? So it's not 3/5 of a foot, folks. It's 3/5 of a piece. How long is 3/5 of a piece?
That's why. Why do you want to ask that question?
Because it's the same as the sugar problem, right? What's 3/5 of 3 1/3 pounds of sugar? What do? Multiply, right? What's 3/5 times 5/6 of a foot, folks? Half. 15/30 or a half. Technically, the extra piece is a half a foot long. So if you add up 29 5/6, you'll get almost all the way up to your 74 2/3 feet. You'll just be a half a foot short. Like I said, this was way harder of a problem than I should ask on the test for this class. So don't worry about this sort of thing, but realize that if you were dividing things up, folks, this is how you do it. You divide fractions. It's the same way when you divide up a piece of pizza, right? So if I cut pizzas into a size of 1/7, and I say that I've got 10 pizzas, and I ask how many pieces do I have, technically that's what you do. You'll say 10 divided by 1/7. And you'll say, oh, that's the same as 10 times 7/1. 10 times 7? 7.
So you just say 10 times 7.
Yeah. But it's really 10 divided by 1/7. That's the real math.
7 and a...
All right, so
Common sense, I guess.
any others of these that you have questions about? Can you do the house one?
Are you going to put the answers online?
I could, yeah. Julie bought a house that's 2/3 the cost of my house. How would you do this one?
Multiply.
How would you do it?
87,000.
Multiply.
Hang on. Which number did I give you, folks?
Julia's house.
Julie's house. Julie equals 2/3 times mine. How do I get my house by itself? It's being multiplied by 2/3. Divide by 2/3. That's how you do this one, right? 87,000 divided by 2/3 equals my house. This is the opposite side of the coin when I was doing the 2/7 for the shoes thing. If I give you the other side, you don't multiply by the fraction, you actually wind up dividing by the fraction. And that's why you write the algebra out, because this one will tell you, because it looks like this, that you need to divide. Because I didn't give you the number next to what you multiplied the fraction by. Okay? So just be a little bit careful with that one. Because that one is another one of those things that I like to throw on tests to see if you're paying attention, right? Well, what is 87,000 divided by 2/3? That's the same as 87,000 times 3/2. What's 87,000 times 1.5? Somebody crank that out really fast. What was that? 730. That's a little too high, I think.
130,000.
Oh, 130,500. Okay, that sounds about right. There you go. So if you take 2/3 of that number, that will get you back down to 87,000, right? But the key is that you had to start at that 87,000 and realize it's the division by 2/3 that gets you up to the 130,500. Alrighty? Alright, so Tuesday, folks. Test.
Are we allowed to have a note card for this class?
No, not for this test. This test you go in cold. Starting in the second test, then you start getting note cards. But first test,
You get no cards in this
Killing
class?
me.
not until the second test.
I get no cards in my last class. What the hell were they doing?
So this one, though, be ready. Again, it's 2 parts. First part is no calculator, so just sit down, crank it out. You turn that in, then you get the calculator part, you pull your calculator out, and then you're done. All right? Oh, stop the camera.